Hi, I'm Matt Suk with MINOX. I want to talk to you just about some basic optics knowledge that'll help you in determining the right optics for your needs. If we take a look at this BV 10x42, the first thing people always talk about is 10x42, 10x44, 8x56. The question is, what does the 10, what does the 42 stand for? Well, the 10, the first number in that equation, relates to the magnification and how many times closer the object appears than it actually is. The second number is the size of the objective lens in millimeters. 42 millimeter objective lens is kind of a standard, whether it's a 42 or a 43, that gets you a good amount of light. Now out of this 10x42, you can actually equate something that's called the exit pupil. Now the exit pupil is the bundling of light that leaves the binocular and hits your eye, your entry pupil. An exit pupil is easily calculated by taking 42, size of the objective lens, and dividing it by the magnification, in this case 10. It gives you 4.2 millimeters. That is your exit pupil. Exit pupil is important in determining how much light a binocular or a rifle scope will let in, and therefore how much shooting light, or hunting light, or glassing light you may have. So that's something to keep in mind when you're looking at different optics, especially because there's a myriad of different objective lens sizes and magnifications on the market today, and you can calculate it quite easily and see which one lets in the most light. One thing a lot of people always talk about is eye relief. Eye relief is the distance from the ocular, the eyepiece, to your eye. Eye relief is very important, especially for people using eyeglasses, because good eye relief allows people to glass while still using their glasses. But it's just as important for people who don't wear glasses. The reason why it's important is because our faces are always shaped differently. For instance, you might not hold your binoculars flush to your face. You might hold them slightly out a little bit. So you want to play with the different eye cup settings that your binocular has to get you the right eye relief to give you the full field of view. The next thing I want to talk about are coatings. Now you have different types of coatings that binoculars, rifle scopes, spotting scopes, etc. use today. One type of coating, very important for today's modern roof prism binoculars, are what's called phase correction coatings. These phase coatings allow the light to pass through a roof prism binocular and not distort your image. Most every roof prism binocular on the market today is phase correct coated. Other coatings you have are coatings on the exterior lens surfaces, on the interior lens surfaces, as well as on the prisms themselves. These coatings help in different areas. Exterior lens coatings can help against any type of dirt, grime, grease, or any other buildup for easy cleaning and durability. Prism coatings, like in our HG and Apo HG, the MINOX coating, help with the overall light transmission. Now, light transmission is basically the amount of light that makes it through the entire optical device to your eye. However, not all light is good light. There's always a certain amount of reflection every time light hits a glass surface. And this is again where the coatings come in to reflect as little light as possible. Now, there's also light that you have to be aware of that distorts the image. This type of what some people call stray light or non-image forming light is a light that comes in at extreme angles, bounces through a binocular or a rifle scope, and therefore distorts your image enough that the quality of the image you're seeing really isn't good enough for what you need. Now, what you have to think of as stray light or non-image forming light is essentially sometimes that glare you get off the car in front of you when the bright sun hits it. This type of light is eliminated through different types of coatings, whether it's on the lens surfaces or say on our BL binoculars, on the interior walls, or the overall optical design and light traps constructed into the body of a binocular or a rifle scope itself. Another thing people always talk about is twilight factor. The twilight factor is simply a mathematical equation that gives you the overall brightness a binocular or a rifle scope can produce at twilight. No quality can be issued to this mathematical equation, but it does give you a nice little overview as to the overall brightness of the optic. The next thing to look at is field of view. Now, field of view in the United States is measured at how many feet you see at 1,000 yards. Say, for instance, in our BL 10x44, it's 342 feet at 1,000 yards. That's how much terrain you can see when you're looking through your binocular at any given time. Waterproofing is simply important to know in terms of pressure changes in altitude, humidity changes, temperature changes, and so on. Most any binocular can withstand light snow or some rain coming on it, but only truly water submersible tested and nitrogen or argon filled binoculars can withstand maybe a drop in a creek when you're crossing it in the mountains, or a more sustained amount of snow or rain. A few other things to keep in mind are some of the accessories that you'll need for your binoculars in this instance. One of the things is very important is a good binocular harness, like this one made by MINOX in Germany. What it does, it spreads the weight across your back and thus allows you to carry your binoculars, in this case a 10x43 Apo HG, along the trails, through the mountains, to your stand, wherever you're going, for a longer period of time without causing any fatigue in your neck. Another thing to look at is if you're glassing over a long period of time, you'd like to use a tripod on occasion. Well, here's one thing that's very important, is to see if your binocular is threaded. In this case, you can just undo the front thread, and it's threaded for almost any tripod adapter there might be for binoculars. On rifle scopes, one of the important things to keep in mind is the reticle. Specifically, what focal plane the reticle is in. Is it in the second focal plane, like with our ZA, ZV, and ZE rifle scopes, or is it in the first focal plane? The difference between a first focal plane and a second focal plane reticle is basically in the size of the reticle at any given distance. The first focal plane reticle, which is very traditional in some military aspects as well as in Europe, as you change magnification, the reticle seemingly grows and changes with it. The advantages of a first focal plane reticle is that your point of impact, regardless of magnification and range, shouldn't change. Second focal plane reticles, which are much more dominant in the United States and actually growing worldwide amongst overall hunters and shooters, the reticle actually stays consistent throughout the magnification range. The downside to this, even though you get less cover of your target, is that your point of impact can change as you change magnification. If you're shooting under 300 or 350 yards, changing magnification on a second focal plane reticle isn't that much of a problem. Your point of impact won't change to the point where you won't hit the target, whether it's a paper target or an elk or a deer. If you're shooting much beyond 350, 400, or 500 yards, changing that magnification on a second focal plane reticle could change the point of impact severely enough that you miss your target.